Welcome back, Algebra 2. We are going to loop back now to 4.1 inverse variation and the reciprocal function. And today we're going to talk about inverse functions and variation and the constant of variation. And then also talk about how to find functions and equations of inverse variations given two values. Okay, so first of all, starting off, let's just kind of check this out a little bit. The two rectangles shown below both have an area of 144 square units. So there's 2 by 72 and 6 by 24. Those both multiply to give us an area of 144. So what are some other dimensions that will give us that same area, right? So we have, of course, 1 times 144. Whoops, 144. What else do we have? We have, if you're helping me out here, we got 3 times 48. Of course, we have 2 times 72 that's already listed, times 72. We have 6 times 24. Let's see, what else we have? 4 times 36. Okay, and what you'll notice here is as my values of one dimension go up, 1, 2, 3, 4, 6, my other dimension goes down. Okay, and that's what's called inverse variation. As the value of one goes up, the other one goes down. Okay, so that's what happens to the width as the rectangle length increases. That is what's called inverse variation, but they both multiply to give me the same value of 144. Okay, so that's inverse variation, is a relation between two variables or two values such that one variable increases, the other one decreases proportionally. All right, and so how do you determine the relationship is an inverse variation? Does the values represent an inverse variation? So what we want to look at, if you always remember, inverse variation means we're going to multiply x and y. So x times y always gives me my value, what we call k. Okay, so if I multiply here, 1 times 12 equals 12. 2 times 6 equals 12. That's kind of a fat pen there. We have 3 times 4 equals 12. And we have 4 times 3 equals 12. And because this is all equal to 12, 12 is what's called my constant of variation. And because this is all the same, that means it is, if that is all the same, right, that means it is a constant inverse variation. Okay, so this is inverse variation. All right, and that means that my 12 right here is called the constant of variation. Because it's constant, right? Constant of variation. Because it's always the same. It doesn't change. Constant of variation. Okay? And so that is inverse variation. What about this guy here? Right? X times y. In this case right here is 20. This is 34. So we can immediately stop right there and say, no, this is not inverse variation. Okay? It's not inverse variation because x times y is not the same number every time. It's not constant. Okay? This guy right here, we have 6.6 x times y. 6.6 times 3 is 19.8. 5.5 times 5 is going to be 27.5. And so again, therefore, no, it's not inverse variation. Okay? Okay, so this is kind of just to wrap it up what inverse variation is. When a relation between x and y is an inverse variation, we say that x varies inversely with y. It's a function where the product or the multiplication of x and y is a non-zero constant. If it was 0, then k would just be 0, and that wouldn't be any kind of variation at all. Okay, so inverse variation is always multiplication. K is my constant of variation, so that's a number that relates the two variables. It's always the same. So notice in this table here, my constant of variation is 24 because 1 times 24 is 24. 2 times 12 is 24. 3 times 8 is 24, and so forth. So you can kind of notice here, as x doubles from 1 to 2 to 4 to 8, then my y gets cut in half from 24 to 12 to 6 to 3. Okay, so as one's going up, the other one's going down. Okay, so that is kind of my inverse variation in a nutshell. So if you remember back to Algebra 1, we dealt with direct variation, and that was when it's basically kind of like a linear equation, y equals mx plus b, right? Mx plus b, except we don't have any kind of, it's the equation where it passes through the origin. So it doesn't have a y-intercept. It has a y-intercept, but it's always 0. So we call the special slope here is k, and that's what direct variation was. And it's always written as division, y divided by x. So my constant of variation this time is y divided by x. Over here in inverse variation, sometimes this is called indirect variation. You might see it that way, written as that way as well, as indirect. What we call inverse is when x times y equals k. And if you want to write an equation where y equals, it's k divided by x. Up here, if I multiply x on both sides, I get y equals k times x. Okay, so this is my equation if I want to write it as an equation. Okay, this is my equation here, my equation over here. Okay, and down here is how they relate to each other. So that's kind of how I find my constant variation. In inverse, it's x times y. In direct, it's y divided by x. Okay, so where k is a constant of variation. So this is, we kind of talked about this in direct variation. This is basically a line. An equation is a line where it passes through the origin 0, 0. Okay, this one is going to be a different. We're going to learn how to graph this in our next video. Okay, so we're going to identify, is it direct or inverse variation, or direct or indirect? In this case, we just always look at, well, what's x times y, right? So in this case, it's going to be 88 here, 88 here, 88 here. So that means it's inverse variation. Okay, on this one here, I know 3 times 3 is 99, and this is 28, so it's not going to be inverse. How about direct? So let's take y divided by x and see if that works anything. So 14 divided by 2 is 7. 33 divided by 3 is 11. So this is going to be neither. It's neither direct or inverse. It doesn't fit either the x times y or the x divided by y. Okay, how about here? We got, excuse me, y divided by x. Let's go y divided by x here. So 16 divided by 4 is 4. 48 divided by 4, or 12 is 4. 28 divided by 7 is 4. So here we have actually direct variation. Okay. Over here, oh, we have x times y. I'm going to notice because 16 times 4 is 64. 8 and 8 is 64. 64 and negative 1 is 64. So this is going to be inverse variation. So to be able to decipher which one is which, I'm either going to multiply, that's inverse. Division is direct. I always remember that division is direct, right? Division with D is direct variation, and then multiplication is inverse. Okay. All right. So now we're going to actually use it. So in inverse variation, x is 10 and y is 3. Write an equation to represent the inverse variation. Then find the value of. So this is multiple steps. So first of all, let's just take these two variables here and find out what k is. So we're just going to take x times y. I know equals my k, right? That's what relates the two. So I know that 10 times 3 equals my k, which is 30. So that's my constant of variation right here. Okay. So now when I want to write an equation, if I divide both sides by x, I get y equals k divided by x. Okay. So now I can actually write this equation as y equals 30 divided by x. Now I can do this, find the value of y when x is negative 6, right? So now I can go y equals 30 divided by negative 6. So y is going to be equal to negative 5, okay? Now some of these you could probably do in your head, but you might not want to get in the habit of just doing that because we might end up with funky numbers that you might not be able to do in your head, okay? So make sure you know how to go through the process of finding your indirect or your inverse variation function. So you might want to try this on your own, but in an inverse variation, x is 6 and y is 1/2. So what is the equation that represents the two? So we know that x times y equals my k. So we know that 6 times 1/2 equals 3, right? Sorry, equals k. Shouldn't put that there, which means that 3 equals k. So that's my k. Okay. So then if I take this over here and take my y equals my k over x, then I can just plug in my k there, which is 3 over x. Okay. So that's my equation right here. That's what represents my inverse variation. What's the value when x is 15? So now I can just take this and go y equals 3 divided by 15, which then y equals 1/5. Okay, so when x is 15, y is 1/5. All right, so now we're going to put this into an application. On a guitar, the string length S varies inversely with the frequency. So in other words, the length times the frequency gives us our constant variation. If the frequency of a 26-inch string is 329.63, what is the frequency on the string when it's 13? So we're going to take our string length, we'll just call it S times F frequency. That's going to be our constant of variation. Okay, so we know we have a 26-inch string times 329.63. That's going to be our K. So let's get our 26 times 329.63 is 8570.38. That's my constant of variation right there. That's going to be my what relates it to. Okay. So now what's the frequency of the string when it's 13 inches long? All right. So if I have my frequency is going to equal, because we're solving for frequency, we don't know what that is, right? We're going to solve for frequency. So we want to go K over S. Okay. So my frequency is going to equal my 8570.38 divided by my S, which is 13. So therefore, it's going to be 659.26 is going to be my frequency of a string that's 13 inches long. Okay, so I can challenge you to kind of pause this and see how you do with this, and do this on your own, and come back and see how you do. Okay. So amount of time it takes an ice cube to melt varies inversely, that means multiplication, to the air temperature and in degrees. So at 20 degrees Celsius, the ice cube will melt in 20 minutes. How long will it take the ice cube to melt if the temperature is 30 degrees Celsius? So I'm going to say the time, I'm going to let time equal T, excuse me, and the air temperature, I'm just going to call it air temperature, is all going to be A. Okay, so you know that T times A is going to be my K. Okay, so at 20 degrees Celsius, that's my air temperature. 20 degrees times 20 minutes is 400. So that's going to be my K. All right. So then I know that my K equals, so to say how long will it take to melt, so my K over T. Oh, sorry, I got that mixed up back here. Sorry. We want to know our time. It's going to equal K over my air temperature. So 400 divided by 30 is our air temperature. So 400 divided by 30 is 13.33. So about 13.3 minutes it will take for the ice cube to melt in 30 degrees Celsius. So a little bit faster than 20. Okay, so there you have it. You have an Excel in Google Classroom 4.11 for day one. The next video we have, we'll be talking about graphing these crazy functions. Okay, have a good day, and I'll see you next in Zoom. Bye-bye.